Hello guys, welcome back to another AIME problem solution video. Today we have another problem here, and as always, we'll start off by reading the question. So, let a10 equal to 10, and for each integer n that with n being bigger than 10, let an equal to 100, an minus 1 plus n. From the least, n is bigger to 10, such that an is a multiple of 99. So we have the recursive formula here, so let's try and find the sum of the numbers from an to a10. So I'm going to write it out. So an plus an minus 1 plus all the way down to a10. Now this should equal to, I'm going to split it up into two parts, an plus an minus 1 all the way down to a11 plus a10. Now from here, we can plug in the recursive formula here. So we can see that this should equal to 100 an minus 1 plus n plus 100 an minus 2 plus n minus 1 all the way down to 100 a10 plus 11. Now, since we have a10 is going to equal to 10, we can just plus 10 at the end here. Now we're going to put these into groups. So we group up all the 100 an minus 1, so minus 2's, and we get 100 an minus 1 plus an minus 2 plus dot 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 all the way to a10. And then here we can look at the others. So we have n minus 1 all the way down to 11 and 10. So here we have plus n minus 1 plus all the way down to 10. Now here we can simplify it yet again, so we still have the 100 here, so the 100 an minus 1 plus an minus 2 plus all the way down to a10. And here, because this is sort of a arithmetic sequence that decreases by 1 every time, we can turn this into n plus 10 times n minus 10 plus 1 divided by 2. Now, this is because in an arithmetic sequence, we have n minus 10 plus 1 terms, and the first term plus the last term is n plus 10, and we have to divide by 2. Now, from here, we can look at this part of the equation from the original, which is the an all the way down to a10. We can move this over and solve for an. So an is going to be equal to 99, an minus 1 plus an minus 2 plus dot 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 all the way down to a10 plus n plus 10 n minus 9 divided by 2. Now here we don't need to care about the 99 anymore, as this part is obviously going to be divisible by 99, so we can forget about this part, and we just need to look at this, which should be divisible by 99. So now we're going to look at this separately. So n plus 10 times n minus 9 divided by 2 should equal to, let's say, 99k, where k is going to be a positive integer. Now here we can actually forget about the divide by 2. And why is this? Well, from here, for n plus 10 and n minus 9, we can see that no matter what n is equal to, so if n is equal to odd or even, one of these is going to be even. So we don't really need to look at this anymore. So now let's try and see what n value would work for this. Now for this to work, we see that n plus 10 times n minus 9 needs to be divisible by 9 and 11. So let's look at n plus 10 is going to be equal 11, as 11 is a prime integer, is a prime number, and should be easier to solve. So for n plus 10, we can see that n is going to equal to 12, 23, 34, 45, and so on. Now, a reminder that n cannot equal to 1, as then this would be negative. Now we can see here that plugging in n equals 12 into n minus 9, 23 into here, 34, and 45, we see that 45 is the only one that works. This is because 45 minus 9 is 36, which is divisible by 9. Now let's look at n minus 9. So n minus 9 is going to follow a similar pattern. We have 20, 31, 42, 53, and so on. However, 53 works, as 53 plus 10, or 63, is divisible by 9. However, since 45 is obviously smaller than 53, we see that as the answer states. To find the least n, we can see that n should equal to 45. So the answer to this problem should be 45. Thank you guys for listening. If you have any other way to solve this problem, please let me know down below in the comments, and thank you guys for listening. Bye!